everyone. Let me know if my voice is not clear or I need to be louder or something. So feel free to speak and stop me at any point of time. So, my name is Arvind Krishna. I am a PhD student here at Georgia Tech in statistics, and I'm TA for this course, Introduction to Analytics Modeling. And since some of you were having problems with R, we decided to take this session. So let me tell you a brief outline of this session. So okay, with the basics, the basic functionalities of R, and then I'll be just seeing how to develop a model in R, and then go over some stuff like for loops and while loops, which are used to make code compact if you need to do one operation many times. Okay, please feel free to interrupt me at any point of time if you have any questions. Okay, let me begin. So, first of all, how to install any package in R. So it's simple. The command for that is install packages. So looking at homework on KS neighbor clustering. So I use this package called KKNN. So suppose I want to use this package because it will help me to build easily. So I just write install.packages here in this R. So let me show you how to open this script. So when I want to write a code, you just go to the top left corner and select R script, and then write a code here. If you want to run any command which is very short, which is one line thing, then you can directly use the console, which is window, bottom left corner. So like you just have to say that equal to 1. So you can write here, and then your x is 1. But if you have to write a long code, then you can use this R script. So I just installed packages, and within double quotes, I mentioned the name of the package, and then I just execute it. So how do I execute it? In Windows, you have to just press Control plus Enter, and you can press Command and Enter. It's installing. Yeah, it is now. So now, after you install that package, you need to load that package. So if you install it, it doesn't mean that you're ready to use it. If you want to use it, you have to load that package, and for doing that, you have to say library KNN. So let me execute this command. It is loaded. Another load the package will be to go over packages here. Is bottom right window, and if you go packages, you see a list of all the packages that are there in your machine. I have all these packages, and let me see if I have installed. Yeah, so here you can see KKNN has been installed, and a tick mark shows that it is currently in R, as I said, library KKNN. If I don't want to use it, I can just click it and get off it. But if I want to use it, I can select it. So also you can select a package. Then for building model, you have to import data, and I want to export some files also from R. So you need to define your working directory, like from which directory should R read your data, and from which directory should R export your files to. So WD stands for get working directory. If you just run this, you will get your working directory. So right now my working directory is users/Krishna, but data is not there. My data is in this directory. So in the homework data, credit card data for this tutorial. So my data in this directory. So I need to mention the path to this directory R. And if I do that, I need to tell that my data is in this directory. So I use this command set SWD, which is for set working directory, gives the path of this directory within setwd, and make sure you use / when you are giving the path. If you're using \, then you will have to give 2 backslashes. So either will work. So now I have to read the data. So for reading data, I have several ways to read the data. So your data was a text file. So I just use this command read.table for reading text files in R. So I just read.table, the name of the file. And if file already contains header, I say header equal to true. So just need to write T for true. And is CP stands for separation. So in the text file, my data is separated by a tab. So I have a /T. So that R will know that how your columns separated. So if I just run this, one second, I cannot run. Yeah, I cannot check working directories. So I ran the working directory line. Then now I'm loading the data into R. So when you load you can data is here, and to show data you just click on it and you can data. All right. So and in a CS file, then you just use read.csv to read data, and that way also. So and now if I check, yeah, data. But when you use read.csv, it gives you an extra column, which is the row number of the data. So if the first column X, it was not there in your data file, but this got added, and suppose you don't want to use this column, so I remove it. So if you want to remove first column, you just say data. You just assign data, all those comma minus. Whenever you have to access any row or column in data, you get data, and within square brackets you can write row comma column. You want to eliminate the first column, so you don't write anything for the row. You leave it blank and you just say -1 for column. So it will remove the first column. So if I run this, check, yeah, now my column is gone. Okay, we have our data. Now subject to remove many columns from the data. So, and maybe you want to remove by names. You don't want to see that you want to remove the first column or the third or the fifth column. So if to do that, you can use the subset command here, and you can give your data name, and you select which columns you want to keep. So the minus sign before these columns A3 and A8, then these columns will be removed from your data set. While you have no sign, then only these columns will be selected in your set. So this is also a very handy function in R, which is quite useful. Then some things, how to find the number of rows and columns in the data. So for number of rows, you just say n row data. So number of rows are 54, and of columns you can call data, and the 11 columns. How you export data as a CSV file. So suppose you want to export the data that you just you want to, I mean, you will obviously want to export something useful, but suppose we want to export data right here, swipe.csv data, and then I'll just give the name of the file that I want to extract data as. So I just run this command. I will see that it has a file in the in my directory. Let me find tree. So yeah, here it has written this file in this directory. Okay. Any questions so far? Yes, or too slow? Let me know if you have comments. So now, define structures. So find different kinds of variables in. Okay, thank you. So yeah, so you find different types of variables in data. So you just want to store a number, you just say var and arrow 5. So the value is 5. If you have to find a vector, you say vector is an arrow. You just C for a, and in the bracket you write the elements. So now your vec is 1, 2, 3, 5, and if there are say alphabets A, B, Z, then you just do it like this. Then suppose you have to define a matrix in R, then use the matrix function. Suppose your matrix elements are 1, 2, 3, 4, 5. Your rows are 2 and columns are 3. So you just use this function and the matrix. Similar characters, you can define. But obviously, are very trivial operations. Most of the very operation that you will have to do most of the times is converting data frame into a matrix, because some of the functions in R will be using matrix and not a data frame. So then do using as.matrix. So that we have import right now in R is of the format data frame. Now, how do you know that what is the format of your data? Suppose you are confused, you don't know. So you type class where the thing is whose data type you want to know. So they will know what type it is. So the data frame. So if I type class of mat, it's a matrix. So you can only use the matrix in your function, and you have to use all the columns of the data, and you want to convert it into a matrix. So you say mat as.matrix data, and now if you see what is mat, it's data into a matrix form.
Is that an integer or as opposed to matrix?
Data frame is a form is a format of data storage in R. So the thing with it is that various operations on a matrix, like you can multiply matrices, but you can do that with a data frame. So if your data is such that you want to perform matrix operations on it, then you convert it into a matrix. But usually when you will import data, it will import as a data frame. So if you want like read.csv or read.table, then your data will be imported as a data frame. So you cannot perform any operations on the data frame. You can run matrices. So that's why I convert. So am I clear? Did I answer your question?
Yeah, it sounds like a frame is a scalar versus a vector. The matrix being a vector.
Frame is a scalar versus a vector. Okay. Okay. Yeah. So.
Because apparently you can do math. You can't do all the kinds of math you want to. But with a matrix, you could multiply a matrix by another matrix, or
yeah, that's right. Yeah, so I have not gone into I can't recollect a formal definition of a data frame, but yeah, when you input the data, it's in a data frame, and it's easy to fill rows in a data frame. It's easy to perform data plating operations on a data frame. I think like if you want to find trends in data, or if you enter data, then data frame is easy to use. So I think that is why we use it. If you have to perform matrix operations, then we fix. Okay. So, yes, there were a few basics. Now I'll show you an example of a model that I built. It's like I just solved one of your questions in your homework, but I solved in a different way. So I'll just show you one of the possible solutions. So how do you begin your model building? So the first thing that I do is clear my environment. By clear environment, I mean remove all the labels and data which are here, which you can throw in the environment here. So I do this. So I don't mistakenly use any of the existing variable in my model. So now then I set the seed. So how do I do that? So whenever you are whenever you are generating random sample in your model, or whenever performing an operation which produces different results every time you run it, then you won't be able to replicate the same result. If you want, suppose you build a model, a random sample from a data, then you want to show the results to somebody else, and you run the same command, then the sample that you generate will be different. So your results will be different. But you want to show somebody else the same result that you got when you were building the model. So to retrieve results, you set the seed, and you put, I put 1 here. You can put any number you want. So if I seed as 1, I will get a random sample each time. Every time I run that command. So I'll get that in a while. So yeah, here I'm building a k-nearest neighbor. So the thing that I will do is I will divide my data into training and test data sets. So here I'm taking 2/3 of my data as training and remaining as test data set. So I just store the number of rows of the data in a variable m. 1 second. So I moved all variables, so now it doesn't know. Let me run. Let me data again. Yep. So now it knows data. Yep. And now I set the seed as 1 and stored the number of rows of data into a variable m. Sample. Randomly select 1/3 indexes from all the rows in the data, and I will select those indexes. So that will form one data set, and the remaining indexes will form another data set. So let's this command. So this is a sample function. So I'm is to m. That means from 1 to 654 rows, and I'm selecting 1/3. I'm selecting 654 by 3 rows, acting without replacement. So what my will look like is this. So the variable looks like this. So these are 54 by 3, 218 selected. So now I have a training data and a testing data. So I name my training data as d.learn. And so now earlier I can access rows and columns from a data as data square bracket row comma column. So I don't have to select the corresponding to a variable val. So I say my val and I solve the columns. So when I do this, I make a .learn which has 2/3 of the observations, and the rest of my observations go in my testing data d.valid. So I use this inbuilt function to train my k nearest neighbor model. Don't worry about this function. You could have made that model without using this function as well. So just chose to use this function. Is being recorded. I chose to use this function. So here my response variable R1, which is a binary variable, and the data my trade is d.learn, and I'm making model for so I will be doing a cross validation to select my model parameter k, like many neighbors I consider when I want to classify a new data point. So k max 100. That means it's always 1. So I'm starting from one neighbor to neighbors, and I will see that what I get, like what is the validation error I get for each value of k. So being asked that what is the difference between minus val and val again? Okay, so eliminate some rows from the data. Use minus val. Like here, I wanted to eliminate all the rows of the data which corresponded to the values in my variable val. So I said minus val. But if I want to keep all the rows corresponding to the values in val, I say val, comma the columns. So difference between minus val and val. If it is not clear. Okay, so I too much about the kernel. So here just means that what the distance, how I'm measuring the distance between neighbors. So I'm using a rectangular distance as my measure. There are many types of distances. You don't have to worry about this right now. So let me run this command. Yeah. So now my model has, my model in this variable fit. So I'll just see what is my fit. Yeah. So it automatically gives me the best value of k, which is 38, and it also gives me the mean squared error I get when I take this value of k. Here the square error will mean the misclassification error because we have a binary model of my data is being misclassified. So that seems to be okay. Every time you fit a model, every time you use a function like this train.knn which fits a model, binary model, I mean my response variable has only two values, 1 and 0. Sorry about that. Yeah. So fit, I use a function like this to fit a model. I can plot the model parameter by using the command. So let me show what happen. I say plot fit. That will be more clear. So I do plot fit. It gives chart. The mean square error, which is a misclassification error, for each value of k, and the number of neighbors that I'm considering to classify an unknown data point. You can see when k is 38, I'm getting the minimum misclassification error. So I should use k equal to 38 here. For the graph, you can zoom, and you can also export this graph, and you can click on Save as Image, and you export it on your machine and use it in your report. There's stuff like you can put title. Yeah, so that is it. Yeah, I have developed the model on my training data. So now I want to test it on my testing data. So this is a very common command, which is this is a very commonly used function, predict, which goes with all kinds of model, logistic regression, linear regression, and other models which you will be learning in this course. So I have to predict if I predict the value, the response variable for an unknown data. So I just say predict my model, which is fit, and the unknown data set is dot valid. But sorry, no, I should not say unknown data, but the test data. The test data is d dot valid. So just and predict use for all the points in my test data. Rounded off the predicted value to 1, since my response variable is 0 and 1. So actual values in this field PRET, they are between 0 and t. So I just rounded them off. Now, if I want to see the prediction accuracy of my model, I want to see how many values did I misclassify. So just make a table of my action, which are stored in this spread underscore bin, and these are the true values. So d dot valid is my data, and the column which contains the my true classification is R1. So I label values, and let's see what do I get. So this table, if I use the table function, see that when my for 107 test cases, whenever the response is 0, I am predicting 0. For 20 test cases, when the actual response is 1, I am predicting 0. And really, when my actual response is 0, 7 cases I'm predicting it to be 1, and for 84 cases I'm predicting the response 1 correctly. So this classification here will be my accuracy here will be 107 plus 84 divided by 107 plus 84 plus 20 plus 1. So about 88 observations in the text data, I'm able to predict correctly. So my accuracy is 88%. So in R, add by using this symbol. Okay. So now talk about looping in R. So loop used if you want to perform the same operation over and over again. So here is an example of a for loop. Should have the same total. The column. So there's asked right now that should the two columns have the same total. So let me see. So in this, they do have the same total. Okay. I think it's a coincidence. So the need not be 50% plus one response and 50% zero response. It could be anything. So I think the coincidence that in so the two totals are not equal. So this is 104 and this is 114. So yeah, so they need not be equal. The total is okay. The question is the two columns combined should equal the number of records in the D-valid data set. Yeah, that's correct. Yeah, because that will be the number of observations, right? Okay. If you have any other doubts, or I will continue. Okay, so we have so yeah, let me begin with for loop. So very simple thing to do. So suppose I want to print prime numbers less than 50. So I'm going from 2 to 50. So I just say for I in 2 to 50. There's a command in R called if command. So here I am just checking if I is prime number or not. So let me after a while. If it is, if this is true, then the flow control will enter this parenthesis and it will print the number. So that is, and so how I'm checking whether the number is prime or not. So this operator, which is %%, it calculates the remainder for two numbers. So suppose I say 7% 4. So my remainder is 1, and 79% 4. The remainder is 3. So I'm counting the remainder of my number I with respect to 2. So I'm calculating the remainder for 2 and up till 1 minus the number. So suppose if my number is say 49, so I'm dividing it by 2, 3, 4, 5, 6 up till 48 and finding all these remainders, and I'm getting but the minimum of these remainders is not 0. That big X. So if the number is divided by any number smaller than a number, that means it is not a prime number. I'm just checking that the min remainder should not be 0. If the minimum remainder is 0, that means it is not divisible by any number smaller than it, and so it is a prime. So yeah, so let me just run this part of the code so it is clear. So suppose my I is 40, then what is happening here? Yeah, so 57 modulus 2 colon I minus 1. I call these numbers. So the remainders. Please just switch your mic if you could please be on mute. I can voice. Okay. Thank you. So yeah, so you can see that none of the remainders is 0. That means it's a prime number, and hence flow of control enters here. So for the special case, so I have to deal with it separately. So this pipe is an OR command in R. So if you want to put in between two conditions, you use this double pipe. So if either condition is true, if either condition is true or I to it will print I. So let's see whether it runs. And yeah, it does. Okay, so these are prime number T. So you use for loop when you know how many iterations you have to do. So here that you have to go up to T. But suppose say that you have to find first 50 prime numbers. So now you don't know how many iterations you need to do. What will be 50th prime number? So in these, when you don't know how many iterations you need to do, you use while loop. So yeah, here I did 2 because I have to get 50 prime numbers. Then define a variable called counter, which will count how many prime numbers have I got, and so that stop when I have reached the 50th prime number. Then I put a while condition that while counter is less than equal to 50, I will be inside this loop. So yeah, this counter is 0 initially. I enter the loop. Then I again check this condition that if my number I is prime or not. If it is, then I enter the loop. I print it. And since I found a prime number, I increase my counter with 1. And then my I with 1, because now I have to move to the next number to check whether it is prime or not. And I keep doing this till I have found 50 prime numbers. And when I found 50 prime numbers, the value of counter will be 50, and will go out of this loop. So let's run this. We get the first prime numbers. So these are a couple of loops that you'll be using a lot in R. Now let's plotting. So now you have this data that we had imported in the beginning of the session, and suppose you want to explore the data, you want to explore data trends, you want to plot each against each variable. So you simply say plot data, and you run this. So you can see that all the 11 variables have been plotted against each other. So these are 11, choose 2 number of plots. See which variables are correlated. You'll learn regression in this course later on. So you'll have to create correlated variables. So you can see here, and you can see which variables are impact or response variable. So if you're interested in R1, you will see which is a trend for any variable which is plotted against R1. So yep, and so that's initially the data. Suppose you want to plot one specific variable against another. So you use this command plot x, y. Now suppose you have to plot say A2 against A3. So say data $A2. So whenever you have to invoke or call any column of a data set, you say data, you say the data set name dollar and then the name of the variable. So it will be data dot A3. And you get, and there are many things that you can do in plot, like you can fill your axes, So how do you find out what all you can do? So if there's a function and you can use it in many ways, and you want to see which all ways you can use, you just go to your console and you put a question mark and the name of the function, and just press enter, and then here you get all the information about this function. So you can see plot xy and what are the other things that you can do. So here I plotted points. If you want to plot lines, you can just say deep equal to L. Yes. For labeling x-axis, you can just say xLAB. For having it, you can say main. I'll show you some of these things here. So you can label your plot. You can tell. Sorry. Plot. Yep. So you play all these options. So yep. So that's so any function you can just type in mark and you will get the help you need. So it's a bit earlier than I planned. So that's all I have for today. So let me know any questions you have and what else do you want to learn that I did not cover. Okay, so I have a question about Kmax. Yes. What types of use? So there's what types of data can I use? $sign. I can use all types of data. I can use the $sign with all types of data. So it's not so dance here numbers, but even if we had a character value, I could call that column using the $sign. You can with anything. Randy, this is your raised hand. Could you speak your question, please?
I didn't get R Studio. So I just downloaded R. Could you walk through to get to R Studio? I know it's I have instructions and I didn't get. I just got R. You know, and one of those. Could you kind of walk through that a little bit?
Yeah, sure, definitely.
Thank you.
So if you have R, then I think just go on Google and write R Studio. And then get it here. Yep, you can just go link. So here we have so just click on download here. Sorry. Yeah, not there. Not here. You can click any of the links here based on your operating system. So if you have Windows, I think you can click here. Mac, you can choose this version. And after downloaded, you just need to double it, and it will guide you to get it installed, and then you'll see it in your program files. So that's it. There's nothing else that you need to do to install RStudio. You need to run the executable file. Let me have any questions. Okay, I'm just some of the questions that I have got on chat. Some of the recitations could we go over using some of the GTXISYE functions and some common R commands? Definitely. I will know that. I was in R files because it was R compared to how do you say in R format. So in R format, I think you just okay. Let me show that. So file, and I want to save it in R format. I'll just click on the save button. It's taking time. Okay. If I have to save it in R, I just say file. I think it's saved in the R format by itself. Let me try. Let me just say save. Oh yeah, I need to write a name and it automatically saves in the .r format. Yep, that's the default format. Yes, is being recorded, and definitely we'll be uploading it so you can see it later. Then we see other questions. Just accept values. So accept values of k from 1 to k max, but then where did you select k equal to 38 to run the prediction? Okay, question. So actually, in this function, we use train.knn. It only uses the best value. So I just show you what is in this variable fit. So if you see fit, it says best k38, so it knows that best k38 and it uses it. Okay, let me see other questions. Can you cover meters C in problem 2A but not by guessing? How should we approach this problem? The model. So in problem 2A of homework 1, you have to model. You have find the cross validation error for different values of C, and then you have to see for which value of C the minimum cross validation error. So it's a trial error thing. Yeah, so there is nothing more involved. You just have to keep trying and the validation error for as many values of C as you can and predict and then take the best value. Then I think that so the record will be up. So we're sending a message that where we are uploading the recording. So right also don't know we'll upload, but we're sending you a message. Can you cover the cv.kknn? It does not give a model like train.kknn does. How would you predict values from cv.kknn? Okay, KNN. I think it is used for just the purpose of cross validation. So yeah, I don't remember the details of it right now. I can definitely cover it in the next session. So I have no. So another is I'm trying to grade the homework problems, but the answer key is a blank right now. Trying to read problems, the answer key, blank page. So the submission is blank. Okay, I will check on this question because I am not sure what's the problem here. So I'll get back to you, Matthew. Um, Valuable to everyone. The best way is to approach the homework problems weekly after the submission is closed. Yes, we posting the homework solutions in which we have together multiple ways to solve the question. So I think your question. Yeah, by the time, yeah, they are already posted, so you can see them. Yeah, when deadline passes, we'll posting the solutions. Okay, 10 o'clock. Keep asking if you have. Yes, so to answer the question of the best ways in which you can solve a problem. So yeah, in the homework solutions, if there is a best way, we will definitely put the best way. But like there are some that cannot be compared, that which one is better, then we will put multiple ways. But yeah, if there is a way which we can call it the best way, then we will definitely mention it in the homework solution. But some hard to compare two solutions. Both may be good in some sense. So in those cases, we'll in that both are good in some cases. Are the solutions in our code and the final answer? Yes, I think, yeah, for homework number 1, we also posted the R codes for the solutions. And yes, you can run them and get the final answer. Website that will allow us to do some more practice with these type of problems. I'll research. I mean, I'll have to do some research on this. So, okay, I entered this question. I'll get back to you on this one. Difference between the train function and the caret package and the train.kknn that you used, for example. Okay, so the train function in caret package performs key-fold cross-validation. Sorry, I should have mentioned this. And the train kknn that I have used here, it performs leave one out cross-validation. So what is the difference? So in key-fold cross-validation, you divide it into key parts, and one part treat it as your test data, while the remaining keeps one part are your training data. So in the data, train the model on your training data and test on the kth data set and in the cross validation error. And this you repeat by counting all your K sets as test data. So you find K of cross-validation error, and you add to find the average cross-validation error, and you compare these cross-validation errors across the value of your model parameter. So in leave one out cross-validation, the value of K is 1. So your test data set consists of only one observation, and your training data set consists of all the other observations. So .pknn performs leave one cross-validation by default, while the train in the caret package performs k-fold cross-validation, where I think you can give the value of k. So that's difference.